Okay. Yes. Yeah. Good evening, all. Yep. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Right. What is Apache Spark? What is Apache Spark? Why PySpark? What is Apache Spark and why PySpark? Need for PySpark. Need for PySpark. Generally, people ask Spark with Python or Spark with Scala. Which one is mostly preferred? And PySpark features. PySpark features. A real life usage of PySpark. Real life usage of PySpark. PySpark job market. What is Apache Spark? Why PySpark? Need for PySpark. Spark Python versus Scala. PySpark features real life usage of PySpark. PySpark job market. Right? Yes. Okay. So starting with Apache Spark. I define Spark in 5 lines. First is what is Apache Spark? What is Apache Spark? Spark is an open source. It is an open source. Distributed cluster computing framework. Distributed cluster computing framework. It is an open source distributed cluster computing framework. With in-memory computing feature. In-memory computing feature. Open source distributed cluster computing with in-memory computing feature in parallel processor style. Parallel processor style. Used for large-scale data processing. Used for large-scale data processing. What is Apache Spark? It's an open source distributed cluster computing framework with in-memory computing feature in parallel processor style used for large-scale data processing. Can say it is a general engine. So what do you mean by in-memory computing feature? In Hadoop also we can see distributed cluster computing framework means your data will be distributed across some multiple systems, processed by multiple systems. You can see parallel processing in Hadoop distributed execution is an open source in parallel process. But only thing is in-memory computing feature extra you can see in Spark. In Spark, we are saying in-memory computing feature. In-memory computing feature. In-memory computing feature. Okay. In-memory computation means storing data within the memory and processing within the memory. In-memory means data storage happening within the memory and data processing happening within the memory. Means if you have got like big data means huge data like TBs and petabytes of data, you need to accommodate within the RAM, within the memory level, not disk level. In Hadoop disk level, it will be stored, right? But not in the memory RAM level. RAM level storage and RAM level processing. That's why we see very high speed for Spark. That's why today in the industry we are using Spark. If you want to achieve very high speed, but the companies which can afford for that huge RAMs, then only can go for Spark. They need to have huge RAMs. Your data will sit in the RAM and processed within the RAM. That's why we see very high speed. I said it is a general engine for big data analysis and for process and computation, right? And why PySpark means simply I can say why PySpark? Why PySpark? PySpark is the Python API. See, generally Spark supports Spark has got multi-language support. Spark can be implemented in multiple languages. Spark can be implemented using Scala language, using Python, using R, using Java. So today, if we see in the industry, Python is mostly preferred. Spark with Python, we say PySpark, right? So PySpark is the, I can say PySpark is the Python API. Python API to use Spark. PySpark is the Python API to use Spark. Spark is an open source. Spark is an open source cluster computing. Spark is an open source cluster computing system which is used for big data processing. Python API to use Spark means yes. PySpark is one of the Python package. It's a Python package, right? So it is one of the lightning fast technology. PySpark is one of the lightning fast technology that is designed for fast computation. PySpark is the demanding tool among data engineers. Is one of the demanding tool among data engineers to work with bigger data sets. To work with bigger data sets. PySpark is used for what? So I can say like PySpark used for running distributed SQL, running distributed SQL, creating data pipelines, running distributed SQL, creating data pipelines, ingesting data into databases. ingesting data into databases, running ML algorithms, working with graphs on data streams. Running distributed SQL, creating data pipelines, ingesting data into databases, running ML algorithms, working with graphs or data streams. Okay. Now, need for PySpark. Need for PySpark. Large amount of data. If you see, we see large amount of data is generated through offline or through online. See, this data is containing hidden patterns, unknown corrections, market trends, customer preferences, other useful information. So it is necessary to extract the useful data or valuable information from this raw data. So require a more efficient tool. We require a more efficient tool to perform different types of operations. We require more efficient tool to perform different types of operations on the big data. These are various tools. These are the various tools to perform multiple tasks. Okay, already we have got many tools available, but they cannot be used for this huge data, and that too, it takes PySpark, it takes very less time, very at a high rate of speed it is going to process the data. So we need to have some scalable and flexible tools to crack this big data, right? And gaining some kind of benefit from it. So PySpark is such a kind. So combination of Python and Spark. Combination of Python and Spark would be the very efficient way for the world of big data. That's why Apache, that's why Apache Spark community came up with a tool called PySpark. That is Python API for Apache Spark. Generally, okay. Generally, people, so Spark can be coded with Spark can be coded with multiple languages. Scala language, Python language. Means the Spark functionalities remains the same, but the language differs. It can use Java language or language. Spark can be coded with Scala language, Python language, Java language, and R language. Scala, Python, Java, or language. So here Scala is the default language, the native language of Spark. Spark by default built using Scala language. Default say Scala is the native language of Spark. Yes. So Spark can also be coded with Python, Java, and R language. So previously Scala was preferred. If you see from 2016, 17, 18, 19, Scala was used a lot. But now if you see from the last 2-3 years, Python is mostly preferred, where Python has got many modules, especially for ML kind of things. Like Python is mostly preferred. That's the reason for this Spark with Python implementation. But still they ask difference between Python and Scala. Python and Scala. Python. Scala means scalable language. Scalable means extension. Scala means scalable language extension, right? Yes. Python is an interpreted dynamic type. Python is an interpreted and dynamic type. Scala is statically typed. So dynamic data types we say in Python. Dynamic means what value you are assigning. If you are assigning x as 10, then integer variable creates. If you say 4.5, float variable creates. If you say string variable creates. Depending upon what value you are assigning, the variable creating dynamically. Python has a huge community. Compared to Python's Scala community is smaller. Understand here? Scala is only for Spark applications only. No other environment using Scala language. But Python is for all open applications. Can be used for all applications. Python can be used for all applications. Scala is Spark applications. Python can be used for all applications. Scala is only for Spark applications. Python has powerful libraries. Python has powerful libraries, especially, yes, powerful libraries. For ML, graph, streaming, etc. Scala also has got, but Scala libraries. One advantage of Scala over Python is Python is slower as compared with Scala. Scala is faster because in Python interpretation, line by line execution, Scala is faster. Except that remaining everything looks okay. Python is slower. Scala is faster. PySpark features. First thing is in-memory computation. I said in-memory computation. Mm. In-memory computation means storing and processing both memory level, RAM level, storage and processing happening both at lazy evolution. Lazy evolution means, see, active evolution, lazy evolution. Spark is lazy evoluted. Which one is better, lazy evoluted or active evoluted? Active evoluted means, for example, you are attending the classes. I'm forwarding the notes. Immediately you are reading that notes, or if you are just exploring that things, right? That is what active evolution. But after 1 month, if I keep exam only, if you are reading, that is what lazy evolution. If I keep exam only, if you are reading, that is what lazy evoluted. And immediately, if you are reading every day, if you are exploring, that is what active evolution. Which is better? Lazy evoluted means lazy evolution in Spark means just like in Python, in programming, right? In programming languages like functions, functions you define it, but they won't execute until you make a call. If you make a call only, then they get executed. In the same way, in PySpark, it's lazy evaluated. The data flow executes only on required, on demand, they get executed. On demand execution of the data flow. On demand execution of the data flow. On demand execution of the data flow, lazy evaluation. Fault tolerant. On demand execution. If you make an, if you perform some kind of action only, then the execution will start from the starting to this, the entire data flow executes. So whenever you perform some kind of action only, then the data flow execution will happen. Until then it won't execute. Fault tolerant. Yes. Fault tolerance. Spark has got a powerful fault tolerance means the Spark data is distributed across multiple RAMs of multiple worker nodes, nodes, right, and are processed parallelly. Generally, I'll be discussing how exactly the data storage and processing happens, right? So in Spark, the data is divided into smaller partitions. They are distributed across multiple RAMs of multiple machines and are executed parallelly. So during the execution process, as multiple systems are running, if any system goes down, then Spark has got a powerful fault tolerant. Means it has got the capability of regaining the lost partitions, regenerating, right? Yes. Immutability. All these Spark data objects are immutable. They cannot be modified or changed. And one more important, like partitioning, right? Spark data is divided into partitions. If they're divided into partitions only, they can be distributed across multiple systems. Then only parallel processing can be happening. Even you can control the partitioning, right? You can increase the partitions. You can increase the parallel processing, right? Yes. One more important feature we see is persistence. Persistence means already you executed a data flow of 40 steps. The 40th step output you want to like later I want to reuse that output. I can reuse, no need to re-execute the 40 steps again. Already executed transformation output I can reuse. Persist, if you persist a particular step output, Means so that the other flows can reuse it. No need to re-execute again the 40 steps. 40th step output is used by multiple flows. The flow step 1, step 2, step 40 is used by different flows. So you can persist that step 40 so that that output can be used by many flows. No need to re-execute again from the beginning. That is what persistence. In brief, I will be discussing if you persist the Spark object so that it will be available in the RAM permanently, then it can be used for giving its output to other. Means permanently means until the session is closed. Okay, so these are the main things, right? In-memory computation, lazy evaluated, fault tolerant, yes, partitioning, persistence, and also apart from this, it has got powerful libraries. Real life usage, right? A real life usage of PySpark. A real life usage of PySpark. In the commercial sector, mostly used. In the commercial sector, it is mostly used. Like in real-time processing, like banks and other financial fields, they are using Spark to retrieve the customer social media information to gain useful insights, can help in taking right decisions. And also like trade risk assessments and data, and also in playing as an important role in fraud detections, even in healthcare, even in healthcare. Even in healthcare, right? Yes. It is used to analyze the patient's records along with the previous medical reports to identify which patient is going to face the issue even after being discharged from the clinic, even in the entertainment industry. It's even the popular OTT platform like Netflix uses Apache Spark for real-time processing for personalized online movies or web series. It processes approx 450 billion events per day that are streamed over server-side applications. Trades and e-commerce. The leading e-commerce websites like Flipkart, Amazon, all these, they are using Apache Spark for advertising, for enhanced customer experience and optimizing the overall performance, and even in the many other industry, like even for tourism industry. Apache Spark provides advice to millions of travelers by comparing hundreds of tourism websites. In this way, we see many of these use cases of PySpark in today's industry. It is a very high speed processing execution model for processing huge data in quick time. See, PySpark is 100 times faster. PySpark is 100 times faster, faster than normal disk processing. Normal disk processing. That's why it has got very high speed. That's why it has got huge demand in today's market. Even if you see uh, the salary packages for PySpark even will be 1.5 times more than other technologies. You should be having that command in this PySpark. So yes. So you can, if you see that course content, what I'm going to discuss in brief in this PySpark, check with this. What is Apache Spark? Why PySpark? Need for PySpark? Spark and Scala PySpark features, real life usage, probably Spark sessions, RTD, repartitioning, broadcast variables up, accumulators, RTD computations, RTD persistence, persistence features, different persist options, memory, disk, memory and disk, PySpark core computation, right? Creating RTDs, increasing the partitions, groupings and aggregations, process of group by key, reduce by key, various inbuilt transformations in inbuilt functions. PySpark SQL data frames, creating data frame, empty data frame, creating a struct type, struct field, row class, column, select collect with column renamed, where group by, join, union, flat map for each. PySpark SQL functions, aggregate functions, window functions, data and timestamp functions, JSON, read and write JSON file. PySpark built-in functions, when expr, lit, split, substring, translate, overlay, to timestamp, date format, array, collect, all this. PySpark external sources. So working with how Spark integrating with Hive, Spark and MySQL, working with different file formats and adding columns, dropping, renaming, handling nulls, window functions, deployment modes, local and cluster mode, PySpark applications, stages and tasks, drivers and executors, building Spark applications or pipelines, deploying Spark applications to cluster, performance tuning, PySpark streaming concepts, integration with Kafka and Spark MLlib, right? So this is in brief, in depth about this PySpark. You can check with this. Yes. In brief, in depth, we'll be discussing about this. It's fine. So you'll be getting the session video of each and everything. The soft copy of this class notes. So WhatsApp group separately for this PySpark. If you got any error, you can keep that error in that group. Yes. All the sessions will be interactive sessions. Even if you want to do parallel, you can do along with me parallelly. Yes. So you'll be getting great command on the PySpark by the end of this course with all this PySpark RTDs, data frames, and DS streams, right? Yes. So this is just an introductory session of this PySpark. So we'll be discussing about this in brief and more on this PySpark Spark data objects, how they are computed, how they are going to be processed. So 2 hours on Saturday and 2 hours on Sunday, 4 hours we'll be having. So it goes for 8 to 10 weekends. Next 8 weekends it goes, right? So it's just an introductory session. Then so many of them were unable to attend today because of this local festival. So we'll continue this continuation of this. We'll be starting the actual things from next week. So we'll have that continuation of this in the next Saturday, right? Same time at 6:30. Yes, you can follow the same link for the next Saturday. We'll continuation for this, right? Yes. Any other queries you got? Yes, anyone? About this Spark, PySpark, right? It's one of the demand tool in the market for data engineer. Any data engineering, right? Compulsory Spark execution is going to happen. Talk about even data factory, or talk about this data bricks or synapse, even that internally Spark execution happens. So it's one of the in-demand tool in the industry, right? Right. Okay. So this is just an introductory session to Spark, and we'll see next. We'll continue in the next week, more discussion of it. Right.